Thanks, everybody. Happy to be here to get to talk to you all about this. A little bit about me. Before coming to Mongo to help build Atlas stream processing rate, my prior company, I was the product manager for Kafka and Flink there. And before that, I worked at a company as their engineering director, helping them build out social media firehose distribution systems on top of Apache Kafka. So really excited to get to talk to you about what we're doing here today. Okay, so, legal always wants you to show this slide when you're talking about future stuff. So read it very quickly, please, like really fast. No? Okay, enough. Let's actually talk about what we're here to talk about. So we're going to talk about why we built Atlas stream processing, right? Kind of like what was the inspiration for us to decide to bring this product into the MongoDB developer stack. We're going to talk about Atlas stream processing itself. We'll talk about the stream processing instance, creating stream processors, and some advanced capabilities. Now, I did have a live demo to show y'all, but the technology gremlins have won out today, and so we're not able to get this up there. So after the presentation is over, if you want to see the demo, I'll show it directly off of my laptop out there in the main meeting area. So that way you can all still see what we were going to show. So why did we build Atlas stream processing? So, we've had the Kafka connector for a number of years, and maybe actually that's a good question to kind of pull the audience on here. How many people are using Kafka today? Okay. How many people are using the Kafka connector with MongoDB? Okay, so we got some folks using Kafka, some folks that have touched the Kafka connector. That's good to know. So streaming data isn't anything new, right? Like streaming systems have been around for a very long time. It's just they've started to gain a lot of popularity as we've moved towards designing event-driven architectures where we're able to react continuously to things. Okay? The Kafka connector was one way, in a very basic sense, that Mongo originally allowed those streams of data to be able to be pulled from Apache Kafka and put into Mongo collections, or for you to be able to effectively take the change streams from Mongo and put it into a Kafka topic. But people wanted to do more. Right? Our customers asked us for more than just kind of this point-to-point integration thing, right? They wanted to be able to transform their data, filter their data, do aggregations on those streams of data as they're moving in between those two systems. And they wanted to do it in a simpler way than what they were able to achieve with the Kafka connector. And there's a whole set of use cases that streaming starts to enable, right? You can take existing use cases that you may have done before, and they effectively can be made more competitive in nature by doing it faster, right? And then there's additionally a set of use cases that was never possible before. I like to think of stuff like scrap manufacturing reduction use cases, where you have manufacturing floors and they're, dealing with physical goods, basically, and if you start making scrap, you're wasting money. Right? And you have to react as soon as possible to stop wasting money. So milliseconds begin to matter. And streaming data is really not that much different than, say, the documents that you're already used to working with inside the database. Okay? So we've got some example up here on the screen. We've got a document in the database. It has _ID. It's mutable, right? You can transform it, you can do stuff to it, whatever you might want to do. And then we've got an event. So you notice it doesn't have _ID, it has _TS, okay? That's because events are things that happen and that's what it was when it happened. It doesn't change ever again. You can mutate it all you want, right? Turn it into something else, so to speak, but at that point in time, that thing was always that way. In this case, it's some sensor data measurements, right, where we're measuring temperature and bar. I can tell you that 88 Fahrenheit is kind of hot in the United States, in my opinion. I don't know bar offhand, so I'm not sure if that's actually a legit value. But you can see, right, really similar. So I think a lot of folks are used to imagining like, oh, streaming data or data that I'm sending to a system, oh, it's super clean, everything's structured the same way, right? They're all coming from the same sensors that are deployed in the field, right? The reality is every one of those sensors that's out there in the field probably has a different firmware version on it, and it's reporting back differently, right? So you have a large variance in how that data can come back, that it needs to be processed. And this works really well for the document model and the aggregation framework to be able to process this kind of flexible data that's showing up. So you can see like our first example, we've got this weather station and it's got measurements, and basically it's reporting measurements as an array. The next one's reporting it just as an object. And then, beneath that, you've got kind of like individual things being reported. Right? And so you get back to that inspiration. Why did we build Atlas Stream Processing? Right? They wanted some easier way, right, to manipulate their data. And so now they can use MQL, the aggregation framework, to do that. So what is Atlas Stream Processing? Atlas Stream Processing, we just talked all about it, built around the document model, flexible schemas. You can use MQL aggregation pipelines to be able to do things, right? The big key, what I would really emphasize here, is that it's continuous, right? Some folks, you say stream processing, those words might seem kind of unusual to you. You're not really sure what it means, right? Another way to describe this is basically a continuous query, okay? You're gonna create a query that never stops running because it's processing an unbound stream of data. And we do other things, right? We do validation, so you're getting in that kind of, stream of data of all those sensor events that are kind of different structures. You want to make sure that they have the fields on them that you need to be able to implement your business logic downstream. You want to make sure maybe there's not certain types of fields or check the data types that they have and so on. And we do stateful windowing. So, an unbound stream of data, if you wanted to calculate an average, right? You eventually have to slice it. You have to create like a chunk, an artificial chunk, so to speak. So that might be every 15 minutes, calculate me the average temperature, right, from all of these sensors that I'm gathering. And so we added operators, and we'll talk later on about those operators, that give you the ability to do that. And of course, it's fully managed on Atlas, so you're able to just go to your Atlas UI. You can go to stream processing on the left. You can click a button. An instance will be immediately created for you, and you can get started playing around with this without having to learn how to deploy, all of the intricate pieces that would need to be, implemented by an operations team for you to use it in prod. So we talked about continuous processing, right, using the aggregation framework. Then there's continuous validation. So we talked some about schemas. That's mostly what we've been talking about, schemas and like the values potentially in that data. But there's also timeliness of data, right? So when you're doing those aggregations over periods of time, right, they're for something from like noon to 15 minutes after noon, right? And you want the data that was created for that period of time to go in that window, right? I don't want stuff from 3 days ago that showed up late because of a network disruption, and it finally got connectivity again, and it sent it to me to show up in this window because it messes my counts and my averages up. That's not the average over the last 15 minutes from today. So we're able to set rules around late data handling, right? Real easy. They're just some extra fields that you set. You say how late you want to allow data to be, basically. And then if data shows up that's too late, or if the data violates your schema constraints that you've defined, we'll send it to a native dead letter queue, right? So right out of the box, data that isn't how you necessarily want it to be, or it showed up late, or, good example, like say somebody did something bad and they created something that divides by 0, right? that data shows up in your dead letter queue. So it's never dropped on the floor unless you choose to throw it away and discard it. Okay. And then there's continuous merging. So this is literally the output, right? How does it constantly materializes into your collection, right? Or your Kafka topic, if that's where you want to write it to. You could be writing it to either or. Obviously, if it's a Kafka topic, this is like an insert-only workload. There's no upsert, so to speak, in Kafka land. But you're effectively able to have a continuous materialized view, right? So you're reading in data from something, you're running a pipeline constantly, and then you're outputting that somewhere for someone to see. This is the 50,000-foot view of this, right? Basically, we can read from a streaming system like Apache Kafka, Confluent, name your Kafka vendor here, AWS, MSK, etc. They all speak something called Kafka Wire Protocol. Okay, Kafka Wire Protocol is actually what we integrate with. So it could be Red Panda, this could be Azure Event Hubs, right? They all speak Kafka, and so as such, we can connect to them. This can also be Atlas via the change streams. And so change streams, if you don't know what it is basically kind of the insert, update, delete event log of what's happening on your database. Okay, so if somebody goes in and adds new records, we can get that record continuously and choose to do some other types of processing on it. Maybe you need to write it to some other collections, or you want to send it to a Kafka topic because you want to syndicate it to other applications downstream. So now, we've got our sources. Now we build those processors. Those processors, again, right, are aggregation pipelines. So if you've been writing aggregation in the database, you already are like 95% of the way there to be able to make a continuous query, so to speak. How many people have used ag today in Mongo? Okay, thanks. And then finally, right, you write it back out. So the output of that processor, either document an event by event, they're coming out continuously, or if you have like a 15-minute window, once 15 minutes of time has gone by for it, it writes out that output that it's calculated to your Atlas database, right? And something to point out here, where these change streams are coming from, right? That doesn't have to be the same Atlas database that you're writing to. You can send it to different Atlas databases. And then same thing to be said for the Kafka system. This can be a totally different Kafka cluster than what you're actually sourcing the data from that you can write it out to. So we GA'd in May. When we GA'd in May, we originally only had one AWS region, US East 1, right? Since then, we've added 10 more AWS regions for you to be able to use. So now we're in every major zone. You can spin up in the Americas if you want, you can spin up in Europe if you want, and you can spin up in APAC if you want to. And so there'll be more slides coming soon that'll talk futures, but this is what's now currently available. We extended the admin API. So the admin API, you might be more familiar of thinking of it as a RESTful API of sorts that lets you interact with the services that you've provisioned in Atlas. So you're able to not only manage your stream processing instances and your connections that you've created that let you connect to things like Kafka or Atlas clusters, but you can also now manage your stream processors that you want to deploy, start, stop, delete, get their statistics, and so on. We added AWS VPC peering support. So this is typically really important with the folks that are reading or writing to Kafka clusters, right? They don't want to have to read or write over the public internet, right? This is a big no-no, can't be doing that. So this gives you the ability to peer your stream processing instances now to your self-hosted or AWS MSK clusters that you're running. And somebody's going to ask, yes, private link support is coming soon for your managed Kafka vendors like Confluent. We added additional processor metrics. And I was going to show you a bunch of these processor metrics in the demo, but basically, we had all the basic ones at GA. Stuff like how many messages did you read in, how many messages did you write out, how many messages got sent to the dead letter queue, right? Because that matters. It might mean there's something wrong. You want to go look at that. Now we've added a lot more stuff like change stream delay seconds. How far behind is this processor from the most current record in the change stream, right? And obviously, Kafka lag matters a lot for folks. So how far behind am I in this Kafka topic? And then finally, we've also added the ability for you to see end-to-end what the processing latency of your processor is, including each stage in your aggregation. How long is that stage taking for those records to get processed to be passed to the next stage until they make it all the way out? We extended our Kafka capabilities, right? So all the Kafka people in the room, but for the non-Kafka people in the room, like Kafka sends a message. That message has 3 parts to it, right? It has a key, it has headers, and it has a value. Usually people just kind of use value and they put their document inside the value and they send it on their way. But there are a set of use cases where people want to use headers or they want to use keys because there are specific behaviors that you can cause on a Kafka cluster. We're not going to get into what those behaviors are, but so now we've exposed those as well in Atlas Stream Processing for you to be able to use. And then finally, we extended our Terraform support. When we first started, we only had the Terraform operators for instances and connections. And what that meant was you couldn't deploy a stream processor using Terraform. You could only deploy the base infrastructure, but those actual processors that are doing the work for you, you still had to kind of go in via MongoSH or use VS Code in order to create them. Now you can create and manage your stream processors in Terraform as well. So all the parts that you need now exist as Terraform operators. Okay, let's talk about the stream processing instance. So the stream processing instance is kind of like analogous to an Atlas cluster in the sense that when you go create it, you're going to pick a tier size for it. It's going to be like an SP10 or an SP30, or sometime in the future we're also going to support what we call the SP50. And all that is a pointer, right? It just says when a stream processor is created and started, I want to run it in this cloud in this region, and the workers for those processors need to be this big and have this many resources available for processing. That's all it does. You don't get charged anything, by the way, for just creating a stream processing instance. It's only if there are stream processors running that you start getting charged. And then there's this thing we call the connection registry. And so the connection registry is where you put all of your secrets for your connections for your stream processors to use. So you're not embedding username and passwords and like PEM files for those Kafka brokers out there that use their own self-signed certificates. You're just using a named entry in the connection registry in your processors, and we'll see what that looks like in a couple slides. And then all the rest of the details are stored securely off to the side, right? Not part of the actual processor definition at all. You'll notice, right, we have stream processing instance and Atlas clusters separate, and I kind of alluded to it when I said you'll pick a tier size. Atlas stream processing does not run on your Atlas cluster, okay? It runs on its own separate dedicated infrastructure. And this is because there's usually a different type of resources that are needed for stream processing workloads. Stream processing doesn't save anything to disk short of the recovery checkpoints that it needs to recover from failure, right? So there's really not a lot of need for me to have potentially terabytes of storage available in order to run this. But it might use a lot of memory if you're doing really big windows over long periods of time, or you have many events that are getting placed into those windows. Okay? And it might use a lot of CPU if you have a very high velocity stream, right? You're processing 250,000 messages plus per second through it, and you have a very complicated aggregation pipeline that it's doing. And so because of that, we have separated this and give you separate hardware profiles. Right? That's also why in the connection registry, you can add many Atlas clusters and connect to different Atlas clusters with the same stream processing instance. So creating processors. Okay. Every stream processor has two pieces to it. It has a source, and this is like where you would insert stuff to read from Kafka or read the change stream from an Atlas cluster, and it always ends with a sink. And this could be a merge, right? Just like $merge that you're used to with the database to write to a collection, or it could be an emit statement to write to a Kafka topic, or to emit to time series collections, if anybody's using time series collections. And in between that, you have a whole bunch of other stages, just like a regular aggregation pipeline. So this could be matches, projects. There's a stage we created called $validate that you could put in there. I've done some stuff with map before and add fields, right? So you have all those options available to be able to put in between there for your processor. And you assemble it into an array, just like you're used to doing with the aggregation framework, and basically the order that you want the stages to execute in. And then you run it. So this is called sp.process. sp.process runs a processor in the foreground. Okay, so like if you controlled C or you exited out of MongoSH, for example, it's going to die. It's meant to be a developer thing for you to be able to kind of iteratively build your stream processor, because it's going to be many stages. And I don't know about you guys, but like on the database, when I would build aggregation pipelines, there's no way that I'm building like a 15-stage aggregation pipeline end to end and then running it, right? Like I build the first 2 stages and I test it. And then I build another stage or 2 and I test it. And so that's what we're letting you do here, right? You were able to run the pipeline, get an output directly in front of you on the console so you can see what it's doing, and then you could like add another stage below, like we add stage Z, and you can run it again and you can see what's being changed. And then of course there's a bunch of other operational commands that you need. There's create stream processor, so you notice we're naming it now, right? Start giving things names and you know they have meaning. So at this point, we're creating a permanent, long-lived stream processor that will run in the background once you start it, right? And then you have to call start or stop, depending on what you would like to do. So once you start it, it just runs forever in the background. And that's that continuous nature of things. There's also other commands like getting the stats, right? We talked about the stats. Or drop it, you could just get rid of it. Maybe you want to list and see all the stream processors that are available, that are on the instance, both running and stopped. And then, of course, what connections you can develop against, right? Like, what Atlas clusters have I added in my connection registry to be able to use? You can just do that right at the command line, and you can get what's available to use for your processors. Technology Gremlins 1. So, out there, if you want to see it, I'll show it to you. And I'll show it multiple times if there's too many people, because there are a lot of people in this room. All right. Other cool things that you can do in the command line or in VS Code, right, is use .sample. So .sample is a way that you can take a stream processor that you used to create stream processor and then called .start on, but you can like hook into its output and it will push this onto the foreground for you and you can see what it's emitting without having to go to the destination, right? You don't have to go set up KCAT to see what's being written to a Kafka topic. You don't have to go log into that other Atlas database to see what's being written into those collections. You can just go pull the output onto your screen and see what's being sent to those places without going anywhere else. We include a lot of Kafka metadata, right? So you've got everything from the key, right, to the time that the message hit the Kafka broker, what partition it came from, what offset it was at in that partition, and then header, the array of headers if you had specified headers. You'll also notice in this little example here, up at the top in $source, we've got a connection name and it says Kafka prod. So in that connection registry I talked about, somebody said, you know, these bootstrap servers, this SASL mechanism with these principal credentials, and named it Kafka prod, and then built a processor out of this. So that's how we avoided, right, embedding those security credentials into your actual processors. You're just referencing it by name. You can specify the topic for Kafka that you want to read from, and very soon here, you'll be able to specify an array of topics. So you'll be able to read more than one Kafka topic at a time instead of just one. And then, you know, if you're using consumer groups, you can set a consumer group ID. Maybe you want to do that because you want to be able to monitor from the Kafka side what the lag is for the processor's consumer group. You might have other reasons that you want to do that too. If you don't specify a consumer group, we'll generate one for you, and it will belong to that processor until you drop it. And at that point, if you ever want to find that consumer group, you can find it under a .stats call. It's listed what the consumer group name is that we generated. And then there's something called time field. Time field is how you can say that this event should be using this time, right? I talked a little bit about windowing and late events and things like that. The default behavior here is to say that the event is from when it hit the Kafka broker, okay? But that can have dramatically different results than, say, if you have like an IoT sensor out there that generated an event hours ago and it has a timestamp embedded inside of its document. You can use that field to represent the time that should be used for this when it comes to windowing operations and things that are time sensitive, allowed lateness values, etc. Okay, I mentioned you can use tons of different operators. Not every single ag operator is available, but lots of them are available. So if you want to do a window over a period of time and use things like first and last, if you want to use top, right, that's easy enough to do. If you want to do conditional logic or use like $switch in things, you can absolutely do that as well. All your time date manipulation stuff that you're used to using with the expression language is made available to you, inequality math, right? But then we created these new things just for stream processing, right? So obviously source emit, we needed those to be able to read stuff in continuously or write it back out to Kafka. But we have two types of windows that are available today. One window is what we call a tumbling window. So a tumbling window is a non-overlapping window. So take 15 minutes of data, do a thing, right? Take 15 minutes of data next, right? Don't recount any events that I've already seen, do a thing, right? And you keep doing that over and over. Then there's a hopping window. So a hopping window is a lot like a tumbling window, but with an offset applied to it. So you can say, take 15 minutes of data, do a thing, right? Move 7.5 minutes, right? Recount 7.5 minutes of old data, count 7.5 minutes of new data, do a thing. That lets you create stuff like moving averages. Here's an example of tumbling window syntax. So you set the interval for the window size. You can set how late data can show up, right? We all know the internet's not perfect. Things can, you know, be arriving and be off by some milliseconds or a couple seconds potentially. So how long do you want to wait for late stuff to show up for the 60-second window before we start sending it to the dead letter queue? And then you define a pipeline, and in this case, we're just grouping by some IP source from some network log, and we're saying, hey, sum this up and count how many times I see this IP. And that's kind of the example you get down here below. You would see, oh, connection count reset 60 times. We also include metadata about the window for you. the start and end times of those windows. It's inclusive, exclusive, right? Inclusive of start time, exclusive of end time. But you can see that's literally the 1 minute or 60 seconds that all that data belongs to that we calculated that window for. You can do the continuous merge thing, right? Continuously create materialized views. I'm glad that I updated this slide with some of the more fancy stuff that you can do because the demo didn't let me show it. So, you connect to your Atlas database, whatever one you had defined in your connection registry. You can say use this DB. You don't have to put static values in there for stuff like collection or DB. You can reference fields in your documents and route that content to those specific collections that you want it to go to. You could even put expression language in there if you wanted. You could put like this massive switch statement that checks a whole bunch of things and then routes things to a high priority collection and a low priority collection and then just like a normal data collection if you wanted to, right? You have a lot of ability to route things around. Same thing works for Kafka topics, by the way. Right? You can parameterize the topic value and route it to different Kafka topics as long as it's the same physical clusters. And then of course, if you're used to using $merge, there's when matched. Typically when matched is like insert, ignore, replace, stuff like that. But we do support doing pipeline when matched. So when you're talking about counting something in a window, right? Let's say you have like a really high velocity stream. It's got 100,000 events a second coming at you. You don't want to write that to your database because that's a lot of raw data that you were just going to aggregate anyway into a materialized view. Okay? So you put a window in there and you count how many times you see this event show up, and then you write a record into the database representing that. Now, another window gets processed because this is continuous, right? There's more data coming in. We're still going to reprocess it, and we'll make another window for the same device that we need to update now. And so when matched pipeline will let you add the value that the window calculated to the existing value that's in the collection in the document that it's trying to update. You don't have to go do like a lookup to try to do that. We'll just push it down to the database, and we'll make the database add it together for you. Schema validation. So we added a stage called $validate. $validate lets you do stuff like use regular expression language to do equality checks, right? Or you can use JSON schema, which is jsonschema.org draft 4 specification. Okay? There's a lot more complicated rules than what I put on the screen here, but you can do things with that are just like saying these fields must always be there, or I want you to do whatever the validation action I've set up is. And you can check data types and data ranges and do regex pattern type matching, all with $JSON schema. So now if a message comes in that violates this validator, you can choose the validation action, send it to the dead letter queue, or just discard it and throw it away. Maybe you want to send it to the dead letter queue because there's something wrong with it, like maybe it should have had a field that it didn't have, and you need to figure out why that was, and you can build some type of out-of-band process for your DevOps or SRE team, whoever it is, to go look at those messages and see if they matter. Setting up a dead letter queue is really simple. You just say this Atlas cluster. So I had talked about reading change streams and writing it out. This doesn't have to be either of those clusters either. This can be another Atlas cluster if you wanted to. And you just set the database in the collection, and you include it in your create stream processor command just by adding it as an option, and that will operate as a dead letter queue. I didn't show it, but if you use sp.process and you have these rules set up for the dead letter queue, it'll wrap the messages that should be sent to the dead letter queue on your screen, so you'll see what it would be sending otherwise. Cool, what's coming up? So we're adding more cloud providers and regions. Azure's on deck, and we're going to get Azure support out there very soon for everybody, along with more AWS regions. There is external functions operator that we're working on. First, it will be for AWS, but basically, as part of your pipeline, that you've created another operator that lets you invoke a Lambda function. So you can write really complicated code if you want to that does something else, and we'll just, as part of that pipeline, send it out and get the result back, and we'll continue on. We're adding more metrics and observability integrations. So today, there are some basic alerts available in Atlas. We're going to add more alerts, right? You'll be able to create alerts based on things like dead letter queue amount of messages over a period of time. You'll be able to make alerts based on things like change stream lag, how far behind it's fell, or Kafka lag, number of output messages over a period of time. And then trigger that to your preferred alerting system, right? You want to send an email, send an SMS, you want a Slack message, you want to integrate this with Datadog. All that stuff was coming for you. And then I think kind of my personal favorite, Lambda operator is really cool. It's right up there. But my personal favorite is the RESTful operator, right? Because there are so many systems out there that just speak REST, right? So just like the Lambda type operator, we'll take that message, but now to whatever URI you have created, we can do a get or a post, or technically a delete and a patch, and everything else as well is available. But so maybe you want to enrich a message with some type of embeddings. You can make a call to something, get those embeddings back, and continue passing it on down the line. Or maybe you want to do a post so that you can update some other system that you're running that, yeah, we've indeed seen this message and we've received it, and this is what it looks like. So Atlas stream processing, right? Native stream processing in MongoDB Atlas. We're using the aggregation framework to let you build these continuous queries. And you can get started today by logging into MongoDB Atlas, and it's pretty simple. There's a tutorial available. If you go to the stream processing page, one of the 3 links will be a tutorial to getting started. It includes a sample data generator so you don't have to connect it to a Kafka cluster or to an Atlas database. You can just use the sample data generator to start playing with and building continuous processors. So with that, please download the app, rate the session. That would be really nice. And then I can take some questions because I've got about 7 minutes of time left.
4 minutes of time.
4? Okay, 4 minutes of time.
One, two, three. Am I audible?
I think you might need the headphones to hear.
Oh no.
1, 2, 3. Do you hear me? 1.
We're good.
Lovely. So a question is actually about maintaining the Atlas streaming, because usually we write code, we commit it to Git, we have all the source control, changes version, and we want to deploy it. I don't really want to use the Atlas UI to write a Atlas stream there, and how to maintain it across the teams. What's the best practice here?
Yeah, I mean, so absolutely Git is kind of like that core fundamental if you want to be able to promote anything into production and know what's going on. You can use, say, the Terraform operator, right, to reference a file, read that file into your Terraform operator. So you do like a git pull, and you pull a specific tag down that you're interested in promoting, and then you run the Terraform operator off of that file that you just pulled down from your GitHub repository, and it deploys it, or maybe your operator deletes it and then deploys a new one, whatever pattern may be there. That's one way. We also have some customers that literally built tooling around the admin API. So they're able to query what processors are running. They actually get the pipelines of those processors and compare them to the ones on file that they just pulled down from Git. And then they'll go ahead and do something. They might do nothing because it looks the same, or they'll stop the processor, drop it, create a new processor.
Any other questions?
Specifically on the MongoDB collection streaming, I'm just interested in the kind of tracking of history there. Do you get access to the actual change event?
Yeah.
Of what it was before and after if you're doing an update?
Yes, so if you're on the appropriate version of MongoDB Atlas that has pre and post images available, because some of the older ones don't, like if you're on 4 or 5, I don't think you have this, but from 6 and beyond, I think is when that starts. Then yes, you can get the full document and you can get the before image as well if you've configured your source stage correctly to do so. And for folks that wonder like about that, that's also really cool because if somebody deletes something and you have before images, you can see what the whole thing is that they just deleted, right? Or if you want to calculate a delta between what field just changed, you can get the old value that was there before and then the new value of what the update was and calculate deltas between things.
All right, we think we've got time for 1 or 2 more.
I think somebody way down there.
Hi. Regarding the dead letter queue functionality, sometimes it makes sense to send something to the dead letter queue if the structure is bad immediately. But what if there is another kind of failure that it's related to network or the database was down for a second? How are you handling this? Are you having any kind of the retry logic?
So there is built-in retry logic. We'll retry a certain number of times. But let's use like an example of saying we can't write to a Kafka cluster anymore. We can't output to it. Right? We're not going to just send an endless stream of messages to the dead letter queue. Okay. Eventually, retries will wear out there, and we'll actually just fail the processor and keep your dead letter queue a little bit cleaner than what it would have been.
And the second part is, do you have any kind of deduplication handling for the messages? So based on the failure, sometimes you might get a duplicate.
Yeah, so deduplication is an interesting problem, right? And I can share with y'all my GitHub repository with some different examples. There's really like 3 ways that you can do deduplication. But because we don't maintain a cache, right? The simplest and most performant way is to deduplicate over time. So we say, build a window, take 15 minutes of data, and you can use something like $root, if you know what $root is in Mongo clusters, right? Then you can deduplicate against the entire document and shrink it down. There's other ways you could use $lookup to look up against a MongoDB cluster, get the message that's already there. You start doing lookups, right? Your performance gets slower. And there's some other little niche ways that you can achieve the same type of result.
All right, last one.
Wondering if there's any future plans for doing source or sync from MQTT?
So right now we are collecting demand for different sources and syncs that customers are interested in. I've heard MQTT, I've heard things like Natch JetBridge, a bunch of different sources like that. If you have a specific request, I would say come to me and let me know, or maybe post it on the community forums, or if you're working with a sales team, let that sales team's SA know, and I would be happy to have a conversation with y'all and figure out kind of where that source sync that you desire lies.
All right, awesome. Well, we're going to wrap it up for time, but if you do want to see the demo, Joe has graciously agreed to do it outside, so feel free to meet him out there if you want to check it out. And if not, thank you so much for coming. We're so happy to have you here, and please make